today is part 1 of 3 parts of chapter 7.9, and we're going to be talking about square root functions. Okay, before we get started, we want to learn about the relationship of where a square root function comes. Now, up to this point, when we have been solving equations, we've used square roots and squares as inverse operations to solve for things. And that is because the functions themselves are inverse functions. Okay, so if we look at y equals x squared, we learned a couple days ago that in order to find the inverse function, we just switch x and y spots and then solve for y. So we would have x equals y squared, take a square root of both sides, and y equals plus or minus the square root of x. Okay? Here if we have our y equals x squared graph, okay, we can make a table, but what we learn with our relations is we can just switch the x and y values. So here 1, 1 stays. This is negative 1, 1. So that becomes 1, negative 1. This point comes here to here, and this point comes here to here, which you can also see we're reflecting over that y equals x line. Now, what is the issue that we have here with the square root function? The issue is that it's not a function. If you remember way back when we talked about functions, we learned about the vertical line test, which if we have this vertical line to test to see if it's a function, well, maybe a little straighter than that. We're only allowed to intersect the graph at one spot. However, here we're intersecting the graph at 2 spots, which means that this is not a function. So here, in order to find our square root, in order to graph our square root, we have to restrict the domain, which means that we're going to eliminate that minus part. Okay, this is going to be no longer here. So we're going to restrict the range, we're restricting the range. The range of our graph is only going to be from 0 and up, so we're not going to be looking at this part of the graph anymore. So whenever we graph our square root function, we're going to be thinking about just the positive square roots that we get when we find our inverse function. Okay? So y equals x squared and y equals square root of x with a restricted range. Okay, they're inverse functions. Alright? So we're going to hop in and figure out how to graph these things. Whenever we think of graphing, we think make a table. So we're going to learn how to make a table and graph these functions. Okay, so the first thing that we want to do is graph y equals 3 square roots of x. Now, the one thing that makes this difficult graphing and making a table is that now we have this thing, a square root. So what we want to do is we want to pick good values so that our calculations will be very easy. So what values of a square root do we know of? Well, that would be perfect squares. So we would have 0, because the square root of 0 is 0, 1, square root of 1 is 1, 4, square root of 4 is 2, and 9, square root of 9 is 3. So all of these numbers, when we put them in our equation, we're going to get nice round numbers. If we were to pick 0, 1, 2, 3, we would get gross decimals, we would get irrational numbers, and then we'd have to round, and then it would just be a mess. Okay, so our goal is to get nice square roots, nice numbers in the square root, so that this becomes a nice even number, and then we can just multiply by 3. Okay? So when we're making a table, we do the exact same thing. If x is 0, then I put 0 into my equation right here and solve. Square root of 0 is 0 times 3 is 0. If I put 1 into my equation, square root of 1 is 1 times 3 is 3. If I put 2 into my equation, 4. Square root of 4 is 2 times 3 is 6. And then if I put 9, I get square root of 9 is 3 times 3 is 9. Okay? And then we come over here and we graph just like usual. Okay? So here we have 0, 0, 1, 3, 4, 6, and 9, 9. Okay, we want to make it that little curve that we saw earlier. It's going to be this curved function, not a straight line. Okay, and we don't go below this point. This is where we restrict it, okay? It also says to state domain and range. If you remember, domain are your x's, range are your y's. Okay, so we have our domain, that's our x, and our range is our y. the best way to do this is to pick this starting point of the graph and write down its ordered pair. So here this is a 0, 0. So that means x is starting at 0 and y is starting at 0. And that's where we're going to define our domain and range. Then we look and see, okay, my x's, which x's go along the x-axis. If I start at 0, does my graph go in the positive direction of x or in the negative direction of x? Well, from 0, my graph is getting bigger than 0. So since we're getting bigger than 0, my domain is x is greater than or equal to 0. Okay? And it's the same thing with y's. Y's travel up and down. So if I'm starting at 0, does the shape of my graph get bigger than 0 or get less than 0? Well, it gets bigger than 0. So then my range is y is greater than or equal to 0. Okay? That is a very basic problem. We're going to add a somewhat slightly more messy square root in this next one. Okay, so now we're going to be graphing negative square root of 3x plus 4. Okay, so we're still going to make a table. And our goal is still going to be the same. We want to be able to take the square root of a nice number. Okay, so when we're taking the square root, we want to always remember those numbers. 0, 1, 4, 9. We want this value to equal 0, so that when we plug in our x, this becomes 0, so when we take the square root of 0, it's a nice number. Okay, so if we want this value to equal 0, how can we figure that out? Well, we're going to take this value and set it equal to 0. Okay, that way, when I solve this, 3x equals negative 4 divided by 3. So x equals negative 4/3. That's telling me what my x value should be. Hence x. Okay, that's my x value. Now, when I plug in negative 4/3, I get 3 times negative 4/3, which is negative 4 plus 4, which is 0. That's what we designed it to be. We designed this square root to equal 0. So we did more work to figure out our x, but now we get a really nice square root, because now the square root of 0 is 0 times negative 1 is 0. Okay? So the work is now coming and figuring out your x values, and then your y values will be much simpler. Okay? So if we want this value to be 1 so that we can take the square root of 1, we're going to do the same thing and set what is underneath the square root equal to 1. Okay, then we solve for x. Minus 4, 3x equals negative 3, x equals negative 1. So again, that is my x value. Okay, and we have designed this so that when we plug in our x value, 3 times negative 1 is negative 3 plus 4. We've designed this problem so that our square root now equals 1. Okay, 3 times negative 1 is negative 3 plus 4 is 1. Square root of 1 is 1 times the negative 1. Okay, so we're designing this problem so that we can figure out easy calculations. From here, if I want it to equal 4, I'm going to set it equal to 4. Subtract 4, 3x equals 0, which means that x equals 0. That is my x value. So if I plug 0 in for x, 3 times 0 is 0, plus 4 is 4. That's what we designed it to be. Square root of 4 is 2, times the negative 1 is negative 2. Okay? And then last but not least, we have 9. Subtract 4, 3x equals 5. Divide by 3, x equals 5/3. So that's our x value, 5/3. We don't even really have to do the math here, but I will just because I'm teaching you. Because we know that underneath here is going to equal 9, because that's what we just set it up to be. This is going to equal 9, that's what we designed it. But 3 times 5/3 is 5, plus 4 is 9. Square root of 9 is 3, times the negative is negative 3. Okay? From here we can go ahead and graph it. So I started my x, negative 4/3 is negative 1 and 1/3. And my y is 0. Then I have negative 1, 1. negative 1, negative 1. Then 0, negative 2. And 5/3, which is 1 2/3, negative 3. Okay, so this one, with the negative out front, it reflects over the x-axis. So now it's like the square root but flipped. Okay, so what is our starting order here so we can state our domain and range? We started at negative 4/3, 0. Okay, so my domain is my x, and I'm starting at negative 4/3. And my range is my y, and I'm starting at 0. Okay, so my x is starting at 4/3. From here, does the graph take my x greater than negative 4/3 or less than negative 4/3? The graph is going in the greater direction. So here we're going to be y is greater than or equal to negative 4/3. Then looking at the y's, y starts at 0. Does my graph take me greater than 0 or less than 0? It takes me less than 0. So here we're going to be less than or equal to 0. Okay? That is part 1. Enjoy graphing.